Hi there. In this video, this is going to be a very special video. I will present here my poem that I have made as my entry to the Lilavati contest of the 7th online Vedic Mathematics conference by the IAVM. That's the Institute for the Advancement of Vedic Mathematics. So, luckily, this poem of mine won the open category. There are four categories. The open category, and I luckily got the second place, and this is my poem. What I was told is that I'm going to give a full solution of what I have here. So I'm going to make use of number theory here, and hopefully you will um, appreciate that. Now, the title of my poem is actually My Age. Okay, so this is by me. Let me read it. In the year 2021, on the month of May, a poem I've done. I'll tell you hints and clues and then guess my age, and here you'll need a pen. I say it is a number that leaves a remainder of 7 when divided by 9. The same number leaves a remainder of 5 when divided by 10. And the same number leaves 3 when divided by 11. Answer this and you'll know my age. So that's the poem that I made. I got second place because of that in the Lilavati contest. And I thank IBM for that, for acknowledging my poem here. So what I'm going to do here is I'm going to present a solution for this poem. So this is shown below. So what we're going to do today is I'm going to give you a solution using the Chinese remainder theorem. I mean, you can get the answer here, the number here, just by trial and error, but it will take a lot of trial and errors if you're going to have that. So we can make use of the Chinese remainder theorem here because we can rewrite these. Actually, we can rewrite this as so let's have it as our first let's have like we have this number x is said to be congruent to 7 mod 9. Okay, so since it leaves a remainder of 7 when divided by 9, so we'll call that x. The same x is congruent to 5, leaves a remainder of 5 when divided by 10. So that's 5 mod 10. And also, this same exact number leaves a remainder of 3 when divided by 11. So this is how we write it in congruence relations, making use of number theory. So x is congruent to 7 mod 9. This same x is also congruent to 5 mod 10, and it's also the same x congruent to 3 mod 11. Now we notice and we observe that the moduli 9, 10, and 11 are all pairwise relatively prime. Okay, so we say that they are pairwise relatively prime. Okay, so we will call this our m sub 1, m sub 2, and m sub 3. So let's name them the m's, the small m's. So this is m sub 1. This is what we call the m sub 2. And this is our m sub 3. Okay, while we call this our a sub I. So this is our a sub 1. This is our a sub 2. I mean, a sub 1 is 7. A sub 2 is 5. A sub 3 is 3. Okay, and since these are all taken care of here, since the moduli, sorry, not the module, the moduli, okay, are 9, 10, 11, and they are all relatively pairwise prime, pairwise disjoint. So or relatively prime. So meaning if we're going to pair each one of them, 9 and 10, 9 and 11, 10 and 11, 9 and 11, they're all pairwise prime. So their greatest common factor is only 1. So we can make use of the Chinese remainder theorem here. So the linear system has a unique solution, as was guaranteed by the Chinese remainder theorem. Every time we have a moduli, a set of linear system, and the moduli are pairwise relatively prime. So to find it, this unique solution, we need to find first the big M sub 1, big M sub 2, big M sub 3, y sub 1, y sub 2, and y sub 3. And these numbers will aid us in getting the value of that unique solution, which are all taken from the Chinese remainder theorem formula. So first we need to find the big M's. So big M sub 1, big M sub 2, big M sub 3. So how do we get the big M the big M's in particular. So we need to recall the formula for big M's. So just recall that just big M as it is, okay, just big M is just equal to all the factors M sub 1, all the moduli rather, M sub 1 times M sub 2 times M sub 3 up until M sub N. Or let's have it M sub N, M sub I. Okay, so since in our example we only have three small m's, so therefore we only have small m sub 1, small m sub 2, small m sub 3. So how do we get the big M with a number? So the big M with a number is just this product except that number written here as a subscript. So when you say, for example, big M sub 1, it's just all the other m's. It's just M sub 1 times M sub 2 times M sub 3 up until M sub I divided by M sub 1. So in this example, so that's going to be 9 times 10 times 11 divided by 9. So our answer is here 9 times 10 times 11 divided by 9, cancel the 9. We have 10 times 11, which is 110. So we're going to make that similar with M sub 2. So M sub 2 will be um, 9 times 10 times 11, cancel the 10, so what we have is 99. So M sub 3 will also be the same, 9 times 10 times 11, cancel the 11, so we have 9 times 10, which is 90. So this is the value of M sub 1, M sub 2, and M sub 3. Okay, so we will be taking note of that. Let me write it here. So big M sub 1 is equal to 110. We're going to make use of this in the future. Big M sub 2 is equal to what? 99. And big M sub 3 is equal to 90. Let me write that right. Okay, now we will be needing this in the future, like I said. Now, we need to move on and find the y sub 1, y sub 2, and y sub 3. And when we need to find that, we need to recall that y sub 1 is a solution to the congruence of big M sub 1, y sub 1 is congruent to 1 mod M sub 1. So this needs to be a solution of this. So we need to find and isolate the y sub 1 to get its value. So remember, big M sub 1 is 110. We don't know this y sub 1. Small m sub 1 is here, it's 9. So therefore we have this congruence. Okay, what we want to do then is to isolate this y sub 1 to make it only 1. Okay, now we can simplify this 110 by getting its modulo 9. Since we are in the universe of modulo 9, we need to convert that back into something like modulo 9, and we need some calculators in doing that. So imagine 9 times 10 is 90, right? So 9 times 10 is 90. 9 times 11 is 99. Okay, and also, if we're going to move one more step, 9 times 12 is going to give us 108, right? So that's 108. 108, okay? 110 minus 108 is going to give us a remainder of 2. So 9 times 12 is 108. That's going to give us a remainder of 2. Therefore, we can simplify this into something like 2y sub 1 is congruent to 1 mod 9. Now, we need to get rid of this 2 by making use of some multiplication strategies. So what will we multiply to 2 in such a way that if we're going to divide it by 1, it's going to leave us a remainder of or rather, if we're going to divide it by 9, our modulo, it's going to give us a remainder of 1. So try to imagine 2 times 5, that's going to give us 10. So 10 mod 9 is 1. So we're going to multiply 5 here. We're also going to multiply 5 here in such a way that it will become something like this. Let me move a bit here. Okay. It will make something like this. So 2y sub 1 is congruent to 1 mod 9. what we will do is multiply this by 5. I mean the whole equation, or the whole congruence rather. We need to multiply this by 5. Okay? So if we do that, what will happen? So 2 times 5 is going to give us 10. That's 10. Y sub 1 is congruent to 1 times 5 is 5, right? And the modulo remains the same. So what we have is mod 9 still. Now, 10 y sub 1, we can simplify this. 10 divided by 9 is 1, remainder 1. So what we want in particular are the remainders. So this becomes y sub 1 is congruent to 5. Sorry. Congruent to 5 mod 9. Okay? And that's our answer for our first, for our y sub 1. And we will call this 5 to be our um, y sub 1. Okay? As you can see here, y sub 1 is equal to 5. Okay? And then we're going to move on to the next. Similarly, we need to find the y sub 2. So we have first the congruence. Big M sub 2, y sub 2 is congruent to 1 mod small m sub 2. So big M sub 2 is 99. Small m sub 2 is, what was that again? Small m sub 2 is 10. Okay, so it's 10. So what we have is 99 y sub 2 is congruent to 1 mod 10. Imagine 99. Okay, 99, if you're going to add 1 to 99, that's going to be 100. And 100 is a perfect congruence of 10. So what we need is, we need to deduct 1 from that 100 to make it 99. Hence, our remainder here will become like this. Sorry for that. 99 y sub 2 is equivalent to negative 1 y sub 2, rather, y sub 2, sorry. I forgot. It should be written as negative 1. Sorry about that. It should be written something like this. Negative 1 y sub 2 is congruent to 1 mod 10. Okay, mod 10. Now, we move on, and then we will see that we have negative 1 here. So what we want to do is to we want to make this positive 1. So we multiply the whole congruence by um, minus 1 to make the left hand side positive. So we multiply this by minus 1. What it will give us is a positive answer on the left hand side. That's going to give us y sub 2 alone, which is congruent to well, it's going to be congruent to minus 1. Okay, mod 10, minus 1 mod 10. Okay, and this will be our y sub 2. Our y sub 2 is negative 1. Okay, now let's move on to um y sub 3. Sorry for this, is a typo. Let's move on here. So for our y sub 3, don't mind this, that's a typo. We want to have big M sub 3, y sub 3 is congruent to 1 mod small m sub 3. So imagine our big M sub 3 is 90. We can see it here. Our big M sub 3 is 90. It's over here. Okay. Our small m sub 3 is 11. So hence, we have that equation there. 90 y sub 3 is congruent to 1 mod 11. And then we have 90. 11 times 8 is 88. So we have a remainder of 2 there. So 2 y sub 3 is congruent to 1 mod 11. So we want to multiply 2 by something like, which will grant us a remainder of 1 when divided by 11. So that's going to give us, times 6. 2 y sub 3 times 6. And then 1 times 6 is going to give us 12. 12 modulo 11 is 1. So 1 y sub 3 is congruent to 6. So therefore, our y sub 3 here, I'll just write it here directly, okay? Our y sub 3 is going to be congruent to 6 mod 11. Okay? And I want to highlight that. Okay, so we have our y sub 1, y sub 2, y sub 3, and we have our small m sub 1, small m sub 2, small m sub 3. We have a sub 1, a sub 2, a sub 3. We have our big M sub 1, big M sub 2, big M sub 3. Now, we are ready to face the Chinese remainder theorem. And recall the Chinese remainder theorem have this general solution. Actually, this can be n, i.e. starting from 1 to n. But we ended with 3, right? There are 3 terms or 3 congruences here. So therefore, we also end with 3. So what we want is to get the summation. This unique solution is congruent to the summation of a sub I, big M sub y sub I running from 1 to 3, which is in mod big M. Okay, what will it look like? It will look like this. Where did all this number come from, sir? So we're going to imagine something like let's have some more space. Maybe I can put it here. Um, we need something like it should look like something like this. So your x, okay, must be congruent to if that's the case, a sub 1, big M sub 1, y sub 1, plus, since it's summation, so we have a sub 2, big M sub 2, y sub 2. This is a 2, by the way, plus a sub 3, uh, big M sub 3, and y sub 3. Now, what are those values here? Now, recall a sub I, or a sub 1 rather. What is a sub 1? A sub 1 is 7. Big M sub 1 is 110. And y sub 1 is 5. So hence what we will have here is going to be equal to, this is congruent to 7 times 110 times 5. Okay, now this is just the same here. How about our a sub 2? A sub 2 is 5. Our big M sub 2 is 99. Our y sub 2 is minus 1. So hence what we're going to put here is going to be 5 times 99 times minus 1 plus, what's your a sub 3? A sub 3 is 3. Our big M sub 3 is 90. Our y sub 3 is 6. So hence what we have here is 3 times 90 times 6. So pretty much the same here, which you can see. And this is all in modulo. I forgot. This is also important. Sorry, I forgot to input it here. This is found in modulo, all in mod. Well, our big M. Recall our big M. Our big M is 9 times 10 times 11. So 9 times 10 is 90. 90 times 11 is 990. So mod 990. Okay. And also, likewise here below, it should be also mod 990. Okay. Now, let's carry on with this. So let's do the maths. 7. I think I'm going to need some calculator here. 7 times 110 times 5 is going to give us 3,850. So this is congruent to 3,850. Imagine there's a minus sign, so this should be minus. Okay, so we have 5 times 99 times 1. So 5 times 99 is 495. So minus 495 plus 3 times 90 times 6. So 3 times 90 times 6 is going to give us 1,620. 1,620. And this is all in mod 990. Sorry. Okay, all mod 990. Now let's do the arithmetic even more. What's the answer? So 3,850 minus 495 plus 1620 is going to give us 4975. So you can see the answer over here on the right side of your screen. So we have 4975. This is mod, sorry. This is mod 990. Okay, and this is our x. This is our unique solution. Now, 4,975 is clearly over 990. So what we need to do is to simplify this, okay, and get the remainder every time we multiply. If we divide 495 by 990, so 4,975 divided by 990 is equal to something like 5. So 990 times 5 is going to give us 4,950. So if it's 4,950, what we need to do is to deduct 4,950 there, which will leave us a difference of 25. So 25, so therefore, this is our answer. Our unique solution modulo, x, is congruent to 25 mod 990. Okay, and this is our answer for um, the poem above. So therefore, your x is congruent to 95, or rather is congruent to 25 mod 990. So hence, my age is 25 years old. Okay, so again, let me show you the poem. This is my age. You can see it here in this part of your screen. Hopefully you're looking at it. So my age is 25 years old. So going back to the poem, so I, in the year 2021, on the month of May, a poem I've done. I'll tell you hints and clues and then guess my age, and here you'll need a pen. So the answer here is 25. Okay, so that's it for this video. Hopefully you got it right. Hopefully you learned something from here. This is making use of the topic of in Chinese remainder theorem, okay, in number theory. So thank you very much for watching and hope you'd like and subscribe. Okay, I think you can see more information about this in IIVM, Institute of the Advancement of Vedic Mathematics, if they have the website already, so you can see the results there. So thank you very much for IIVM for giving me this opportunity, and yeah, I just got second place. Okay, thank you very much again.